All right. Okay, so he.
So this is.
Yeah, so
this is the picture that I kind of drew.
All right, yeah, your picture is actually pretty good. So this is 1 here.
Yeah, so 1. This is the point R, and R is just some number, some number less than 1, between 0 and 1.
Okay. And then
R squared, R cubed.
R cubed. Okay, great. And then so he goes down, and then so eventually, he's got to find a way to shrink the size of these rectangles. So what is his clever idea for making the rectangles shrink?
He moves them. I think he multiplies them by R each time.
Okay. And what do you know? What happens to R?
And R goes to 0. Or like this series goes to 0, and the widths are measured by 0.
That's right. But how? What happens? What value of R makes the widths ultimately become 0?
R approaching 1.
R approaches 1. So it's an interesting and cool and certainly different idea. So in this case, instead of when we're doing these Riemann sums, we would let the width go to 0. But in this case, the width going to 0 means R going to 1. Okay, so interesting. So what is the area of one of these rectangles?
So it's going to be...
I'll let you write here. Yeah, we got room.
So it's going to be the width times, like they're doing it in general, so it's width times this to the n, or the furthest end to the n.
Okay, so you're going to pick the right-hand endpoints.
Yeah.
Okay, so why don't we write down the let's call this the first, second, third. So write down
that's what they did.
Did they? Okay, good.
They start at 1 and go.
All right. So what's the area of the first rectangle?
So the first rectangle has width 1 minus R, and then times 1 to the n.
Okay.
And then we're going to add, for the second one, we have R minus R squared times R to the n.
R to the n. Okay, yeah, I see it. Oh, wait a minute.
R to the n.
Oh, yes. Sorry, I got confused. This is the function x to the n. Right, okay, yeah, sorry. I thought it was 1 over n. I don't know why I thought that.
R squared minus R cubed times R squared to the n.
Okay.
So then this is going to generalize for the general term. It's going to be, I guess, R to the n minus 1 minus R to the n times R to the n minus 1 to the n.
Okay.
And then
Neat.
I'm going to erase this just so I'm a little bit more space. Okay. So then I believe they factor it. So like instead of writing, so they keep the first term the same. It's 1 minus R.
Okay.
And then I think they factor it in R. So they do 1 minus R. And then they take an R out of here and they go R to the n plus 1.
Okay.
And then...
Tell you what, as you're writing across all... Can I erase this term?
You can erase the other.
Okay.
And then they do plus 1 minus R. There's R squared to the n plus 2. And then on and on like that.
Okay, so an R squared comes out of this term here, and there was an R already, an R squared there. So...
or it's n plus 1.
N plus 1. Yeah. Okay.
So then... yeah. So then they factor out 1 minus R. I think 1 plus R to the n plus 1. And then I think they switch the powers around so it's a geometric series. So they say like plus R to the n plus 1 squared.
Okay. And what would the next term be?
Plus r to the n plus 1 cubed.
Okay, I get it. And on and on and on.
Mm-hmm.
Okay, so we have this is a good stopping point for the second video. So, in the picture here, the sum of these rectangles, the width times the height, always has this term 1 minus r,
Mm-hmm.
and it's times a geometric series. And so, what are the next two things we have to do to find what this sums to?
So we have to just simplify this term,
Okay.
and then we're gonna have to find a way to make r go. And then, like, we make r go to 1 and see what it equals.
Okay, great. Super. Let's proceed.